The way in which they differ is in the arrangement of their atoms in stereoisomerism. Simply in this video, we'll just be taking the introductory part of stereoisomerism. So when you're talking of stereoisomerism, you are simply talking of molecules. They have the same number of atoms, they have the same atoms, they have the same functional groups. So, but the major difference between them is how the atoms and the functional groups were arranged. So that's simply the difference between them. Now look at, I have some examples here. Look at this. So this is an eclipse ethane, while this is staggered ethane. Now these two, this and this, they are both stereoisomers. They are both stereoisomers. Now here also I have the cis trans 1,2-dibromo 18, cis 1,2-dibromo 18 and trans 1,2-dibromo 18. So they are both stereoisomers. So as you can see here, now look at it. Now when I talk of they having the same number of atoms and functional group, now look at here. Now this is an atom of bromine, an atom of hydrogen. You can see that the same one that is here is the same one that is here. So can you see? Now look at here. Now you can see hydrogen here. They have the same, practically the same atoms all through. So whether it's functional, they used to be the same. But in the only way in which they differ is in the arrangement of their atoms in space. Okay, now I'll quickly let me first illustrate this with dibromo 18. Now look at here. Now we have our bromine here up here. We have the second one up here. So can you see? So now this is an example of what I call cis 1,2-dibromo 18. This is because they are on the same side. Are you getting it? So now look at the other one. Look at this one now. We have our bromine here, and we have the second bromine here. Can you see? So this trans 1,2-dibromo 18. The reason why it's trans is that the functional group, they are apart from hydrogen, which is bromine. So they are on adjacent side, not on the same side this time around. So that's why it is called trans. So you can see that. So that's just simply the difference between. And this example of isomerism is what you can call it geometric isomerism or configurational isomerism. So that's that. So now back to the staggered and eclipsed ethane. Now take a look at here now. Now this example of staggered and eclipsed ethane is what you can call the conformational isomerism. Now in conformational isomerism, it differs in the sense that there is rotation about a single bond. You can see that we are talking of single bond here in conformational isomerism. Now look here, unlike the other configuration isomerism where we are talking of double bond. So are you getting? Now in the single bond, there is free rotation. You can see that in the single there is free rotation. The stops can keep moving anywhere. Okay, now let's spot the difference between this in the arrangement of the atoms. What are we talking about? Now look at here. Now we have our hydrogen here. So look at this broken wedge here. Now look at this thick wedge, this thick black wedge. You can see the hydrogen here. Okay, now look at it. Now look at it. The hydrogen of the broken wedge is here on this staggered ethane. Now look on the eclipse zone. Can you see now it has changed position here? So that's just simply the difference. Now if you look at other structures from here to here, they are the same. All these sides true. The only difference there is just the arrangements around here. So that's that. So look at now in another structure. This is just the second structure of it. We have the staggered one. Now look at the staggered ethane. See the way it is brought. No, the staggered. The difference between, now look at this. Compare the two together. You will see that these ones are farther apart. Look at the hydrogen here. Far apart, far apart, far apart. Okay. So you can see. You can just say, okay, this is a carbon here. The other carbon was used as a circle, and the other hydrogens were outside. So can you see? Far apart. Look at this one. Now look at the eclipsed one. They were just very close together. You can see that not as far apart as they were here. Look at this one here, around the middle here. Look at this, very close to the second one. So that is very between the staggered and the eclipsed ethane. So this is just a short introduction to stereoisomerism. So we shall still be exploring more of it in the subsequent lectures that will follow. We'll be exploring more. We'll talk about the Warden inversion, the can-equal prelock system. We'll talk about some other things, the SN2 reaction mechanism. So all these things related to stereoisomerism.